Welcome to May 4th LeetCode Challenge. Max number of k-sum pairs. You're given an integer array nums and an integer k. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operations you can perform on the array. So, for example, one we have the array nums, integer array nums 1, 2, 3, 4, and we want to return k equal to 5. So return the maximum two numbers that will that you can perform an operation on them such that it equals to 5. So say if you pick remove the numbers 1 and 4, then you have the remaining numbers 2 and 3, and then you also remove the numbers 2 and 3. Therefore, it equals the null list, right? So there are no more than two pairs that add up to 5. Hence, you have a total of two operations because 1 and 4 equal to 5, and 2 and 3 equal to 5. That's self-explanatory. Let's go to example number 2. So we want to have this array here, and we want to basically have a number that whose sum is equal to k. So we start off with the two threes, right? 1, 3, and two threes, and we're left with 1, 4, 3 left. There are no more pairs that add up to 6, so therefore we're going to perform a total of maximum of one sum operation from the array list. So let's see, we have the constraints of the length of nums between 1 to the 10 to the 5. Each index of the nums is between 1 to the 10 to the 9, and k has any number between 1 to 10 to the 9 as well. And there's some hints here. So this one I'm gonna do my approach is gonna be probably like a set. So I'll call let's see, call a bucket a set, right? And then I can have an output assigned to 0 at the moment. So for I in nums, I'm going to loop through each element in nums, and if there, let's see, if there is a num in our table, right? We're gonna make a bucket set table, in table, and not used. Then what we're gonna do is increment it by 1, or output by 1. So if k minus I in B, our bucket, and B at index k minus I is greater than 0, then we are going to increment our output by 1. We are also going to update our table, right? Our bucket table. So there'll be k minus I, and that's going to be decremented by 1. And that means that it's been used. The number in the array has been used. Right? And therefore we remove it. If that, then we do this. Else, the next condition is if I is not in our bucket, then we want to do is assign B index I to be 1. Right? And then, what am I doing? This else if is else. Else, what we want to do is increment B index I by 1 to know that we have one element left in our bucket. So then at the end of this, we want to return our output. Let's run this. Run the code. See the little hints here. Abstract from, disjoint pairs, given sum, possible each values can be paired, and then such pairs numbers equal to count min. We didn't use that technique. Alright, submit. Okay, accepted. Space complexity is basically big O. Time complexity is big O of n because we use a hash table. Because we use a for loop actually. And space complexity is big O of n because worst case there's no fit in any element, and all elements are distinct, therefore we use the hash table for that as well. You could actually speed it up a bit by using this following. You could, instead of using the conditional statement, we could use what's it called? Let's see. Instead of using this function, you could do if b. You can use a get function from the hash table. So b minus I, k minus I at index 0, and then we could also update this to be b.get I, 0 plus 1 as well. And this should be a little bit quicker. I tested it before, so oh wait, oh never mind. Forgot the equal sign here. Damn. There you go. It's a little bit quicker using the get function. And that is all. Have a great day, guys.